Hi all, this is Hydra 2022 and we're having another exciting talk today. My name is Kirill and today we are having Sasha Kirsanov as a speaker and we'll talk about distributive and collaborative IDEs. Hi Sasha.
Hi, Kir. Nice to see you.
Good to see you too. Very excited about your talk. So I just wanted to ask myself, why would you need remote and collaborative IDE? Why would you even think about it when we all have our local classy IntelliJs, riders, and other of IDEs? And well, I was thinking for a while about that, and I think that imagine you no longer waste your time to start up your IDE, to check out branches, to index things. Instead, in our paradise world, I mean engineering paradise, everything is already preemptively prepared for you, specifically for you. Everything is green, compiled, cached. So you just connect and that's it. And you just start working. Sounds great, isn't it?
It is.
Yeah. Or remember last time we've had a screen sharing session. Uh, Remembering this stuff like no, not this button, this one from the right. You idiot! Here's this button. Yeah. So yeah, we get used to all these local classy IDEs, and but the trend is that we want to make IDEs remote and collaborative as well. And today, Sasha is going to talk about how technically we're going to do this, given IDs are so complicated inside. So please welcome Sasha. Sasha, go ahead.
So, hi all again. Thanks, Kir, for the introduction. It is uh, changing world, and we are moving to the remote and distributed setups, and it's quite easier for people to communicate over the tool which knows about what it works with, instead of just sharing the screen and asking for different buttons, as Kirill mentioned. So today we'll be talking about JetBrains IDE and the way we transformed them from the local desktop application to the server capable of handling several clients, and use this technical platform for both Code with Me and remote development with the Gateway products. But before we start, I'll shortly mention the things that we define as a technical paradise in the future, and what we'll be referencing during the talk and trying to get inside. So the Code with Me allows you to start a session right within your favorite IDE. You click it, you got the link, you send it to your colleague, and the important thing here that the colleague or your friend doesn't have to have anything on their machine. Just the lightweight client will be downloaded, and they will get like instant access to your code and all the features you're used to when working inside IDE. So you can see the cursors moving like in Google Docs, but IDEs are way more complicated and capable and featureful. So all of these features are available to the people joining your session, and you can use that to troubleshoot problems, to do some pair programming, or just talk about the code with your colleagues, or I don't know, launch a classroom and make some teacher stuff. So here it is. Similarly enough, the remote development allows you to set up your workspace somewhere in the cloud on your office machine in a Docker container or somewhere else where you want it to be, and then just connect to it. The important thing that given that it's somewhere, you can pre-build it and warm everything up, and just in a few seconds get the ready application with everything waiting for you to start working on it. With no need to download anything, set up the dependencies, or installing some SDKs, etc. So all the features you're used to when working with the usual setup in local IDEA or your IDE of choice is available to you. So they're quite similar in a technical point of view. They both use the same client, which it was used for the guest in the Code With Me session, or for your usual working scenarios in the remote development. And you can think about remote development from a technical point of view as a Code With Me session where you, the only guest, and the host went to drink some coffee or something. So he's not at the laptop. You're the only user of that machine at that point. So the goals for the current talk is to show how technically it's implemented. And given that I don't think it will be very popular for among of you folks to split up the IDE in the next couple of days, I'll try also to focus on more general ideas, like how to approach a very big synchronous and mutable system, which is quite old, has a lot of different plugins, and how to make that thing ready for the new scenarios, and how you can make a single user desktop application into something which is capable of handling several users at the same time. So same is maybe even more important than the goals is to define something we won't be talking about. So there are a lot of different and very interesting tasks about the infrastructure and the way IDE servers are managed on that remote side, how we are dealing with the security and end-to-end encryptions, how do we compare with certain alternatives, and I'm not going to give a complete documentation of the features. We will be focusing on the things we defined, how to make these things ready for remote and collaborative setups. So we'll go with a small overview about the way IntelliJ works, how the modern IDEs are built, what part they consist of, etc., and what makes it really hard to make predefined and serving well application, which is desktop on, ready to all the new world scenarios. And basically, for the rest of the talk, we will be going for the list of problems and evaluating some ideas which can be used to approach these problems. So the IDEs are pretty complex. They take huge projects. They analyze all the files that you have there, analyze the binary dependencies, and the whole idea of that is to provide you with some features on top of that, so you can actually fix some problems, spot some I don't know, downgrades in the performance or something, and IDE guides you through all the stages of your application, right from the start of when you create one, and when you write some code, digging into problems, analyzing how well it does its job, covering it with tests and running them, working with the version control, and basically everything you can imagine what you need to do with the code, you can do it from the IDE. And to do that, we can tell the several layers of the things that IDE is doing to be able to provide all the usefulness you're used to. So first of all, it takes all the files and launch the lexical and the syntax analyzers on top of that. So it transforms the bare text or binary into some abstract form which can be analyzed, because the IDE knows about the language, etc. Then it actually runs some useful features and inspections, spotting out the particular problems with your code. And as a user, you can work with the various UI elements that is presented to you. Well, actually, the IDEs look like a cockpit in an airplane. It has a lot of buttons, a lot of functionality you can use to move faster and make your life better. But technically, after you've done all of that, you need to render all the things. So it's not a terminal-based application. It has UI. So at some point, there's some UI queue, which is responsible for just showing you the particular pixels in your screen. The typical workflow, like for analysis that can be used to tell that something is missing currently and to create that automatically, is as follows. You start with text, then you split the text into small tokens with keywords, identifiers, braces, white spaces, etc. Then you create a tree. You tell which symbol and declaration relates to which usages, what's the nesting and imported does that, what language version and project setting that you're using. Basically, you gather as much knowledge about the code as you can, just to provide the features later on and make the users happy. So here how the basic IDE feature works. You see that there's some redundant check, IDE spot set, you can remove something, and after that, your code is much better. So to dig into the way we're going to transform the current setup into the way we announced, it's important to define the requirements that we currently have. IDEs have a bunch of various plugins which can be used to extend every possible bit of its functionality, including languages, different test frameworks, or libraries, or whatever it is. And to the user, they all become available and it can work with that, and we should save that. So basically, we want to cover all the features, a lot of different features that exist in local IDEs, to be ready to go remote and collaborative. And we also want to make the user experience to match or even improve compared to the local setup, meaning that you should be able to use your favorite shortcuts, your favorite theme, etc. Even though you're connecting to different OS on your colleagues, or you're running your remote server on some Linux machine. And quite importantly, given that IntelliJ IDE and all the IDEs contains millions of code, we don't have time and resources to start it from scratch. And we need to come up with a solution which will be suitable enough for us to just plug in into this existing platform, extend it, but in a way we don't rewrite it much. Okay, and we also don't want to do at this point any fault tolerance. We don't want to spin up the remote backends and kill them and make some duplication and all the things which is usually required when we're talking about the client-server application. We just want to match the local setups in terms of features and behavior. All right, so we've mentioned the several stages that can be divided into IDEs, and we need to define where we actually want to split that, given that the IntelliJ client, which people are using on their machines to connect to somebody or to their remote server, it's also IntelliJ-based IDE, but all the functionality about the languages and different language features stripped off. So it contains all the basic functionalities such as editor, tool windows, etc., but nothing apart from that. And we have a problem here because the majority of APIs in IntelliJ IDE are synchronous, and as well as the different various constraints and contracts, which was absolutely fine for the local IDEs and local desktop applications, they're not anymore. So we need to do something with that. And what do we want to do? One of the first questions which raises up at what kind of state do we actually want to store on the server? Because everybody wants their servers to be stateless, and everybody knows that the less state we have, the better. It will be easier later on. Or so should we just take one feature and make it remote friendly from the beginning? And the answer is no, because we have thousands of them, and a lot of the features we don't even know about because they are coming from some third-party plugin, which somebody is very fond of and get used to using it. So what should we do? And the basic principles that I want you to bear in mind is that all the layers that you defined, starting from the reading files from disks and to rendering, they all have different amount of data going back and forth. So for the files, it's pretty huge because you can have millions of source code files located in a pretty big project, and you need to read all of them. And if we define to lay the separation at that level, we'll end up using some rsync or a remote file system, which is not enough because the data will be transferred massively. So on the other hand, if we decide to go with rendering as our separation layer, we will end up having some remote desktop-like solution. So every move of the mouse will be transferred to the server, and then something will happen, and you get back the results as pixels. So not good. But the important thing here is that user actually don't see all this work. They see some features highlighted in the editor. They can see the menus. They can see the code or tool windows. And as for the state, so if we don't do anything, it's already on the backend, right? So we kind of got to like live with it and see how it goes. So you've seen the screen of the IDE, but I want you to look at it from the different angle. Like you haven't seen any programming language before, and you see pretty strange frame in front of you. So what do you actually see? The biggest thing here is the editor. So it actually contains code that you're usually writing or going through while trying to understand your project better. But also the editor is used to produce some outputs from the build or some various processes that you launched during the work with the IDE. And what exactly defines the state of the editor? So what do you need to replicate that? So you can see that it contains a text that basically it's a string, right? And you can see the your caret that you move, and you can select some text in it. You also see that the text here is colored differently. So you have the keyword, you have the arcs, which is unused, so it's grayish a bit. And you also see various visual elements on the left side, on the right side. You can see the author changes. It's all the features that, given that we are trying to analyze what type of data is really needed, it's not that much, right? And I want you to imagine the situation when you have exactly the same editor, but created independently. So it doesn't really know about your project or anything. You can do that like in your normal IDE. If you split your editor to the two sides, you'll be seeing the same changes. You'll be typing something, and you will immediately see it on the right side, even though you don't communicate with that. But the difference is that the right part in the local IDE still knows a lot about your project. But here, if we imagine the hypothetical process which has no knowledge about your project at all, it seems like the data what we specified is more than enough to leave the user with the impression that it's quite the same. So we synchronize the caret position, the coloring of the text itself, some visual elements like buttons to run your project. And if we provide the things to synchronize all the way, which is all the small UI pop-ups or various things which is shown on top of the editor using the same approach, given that to show this pop-up, we only need the icons and the text and sub-menus if user clicks on them. So that's basically it. Not a lot of data, right? What else do you see on the frame? You see the toolbars. Basically, it's a rows of buttons or some drop downs. It's really simple. They can be disabled, they can be clicked. So the next major part is the tool windows. We already saw them, and when talking about the editor, they usually define various workflow for the technologies or running tests, so building application or navigating through the files. But the UI in them are usually typical. So you see some trees, and it's icons and the text again, and the proper nesting. You see some text output, some toolbars as well, but that's it. And here is the rest, and that's not much. So we have some status bar on the bottom left, some yet again. So it's some icons, some text, some things you can click on. And we actually covered the whole frame of the IDE. So it was pretty huge and it has a lot of knowledge about the code. It does a lot of work, but all you can see is this. So another important thing is what user can actually do with this And it seems like most of the users, they just have the keyboard and the mouse, and that's it. So if we define the things which can be shown to the user, and there are not a lot of them, and we define the way the user can actually interact with the IDE. So it seems like we're still talking about really small amount of data, right? And when user types something or clicks something, actually everything can be changed as a result. You build your project, you change your settings, or you check out a different branch in the version control. But if it's not visible on the screen, it's definitely important for the project itself to build it properly, so to run it with the correct settings applied, or to test it or whatever. But if it's not visible, you have no way to tell that it was there, right? Maybe you can tell it some time later because some error in the editor didn't disappear. But that's it. And that's the basic idea. So we define the scope which is shown, which can be taken as an input. And we limited ourselves only to the things which are visible to the user. And that brings us to the basic building blocks which we want to synchronize. First of all is actions. It includes buttons and the calling from the shortcuts, etc. You definitely need an editor with the card and the text inside. You also need to synchronize the tool windows and some UI popping up on top of that. So if we manage to do that, we will be done. And to draw some the way it looks. So we define the subsystem we want to synchronize. We will be talking about the synchronizer itself, but you can imagine as it as some thing which takes all the changes from various subsystems, does something with them, transfers them through the network, and passes to the really similar synchronizer on another side, because the real IDE and the client, they all have the same platform they built on top of. So they're all IntelliJ-based applications, right? And so the other part does the opposite work. It takes the changes it received and applies them to the exact same subsystem we decided to synchronize. Okay, so in this new world, when we defined the split for the IDE, even with one user, we started having problems with the synchronous API and resolving all the conflicts, etc., because there are two processes involved, and all of them live independently on a different side of the world. So we already need to do something with it, and that's quite important actually, because usually people think about the conflict resolution only when it's coming to the collaborative text editing. And actually, that problem is solved already, but there are a lot of different subjects in that, except for text. So what do we need to do that? I want you to take a look at very simplistic emulation of the caret. Though basically, it can be described as an offset. Obviously, it's way more complex than that because it handles the different languages and the Unicode symbols, and you also have various coordinates because some of the text can be folded, you can switch them and move to some place. But very roughly, it's like an integer, right? And you have a setter and getter for that. But how do you actually make that? How do you sync that? And you can skip the refactoring all the subsystems which has the synchronous API by the means of attaching listeners to the needed data. And the important thing here is that we still have the synchronous API, right? But we also have the way to collect all the changes in the proper order. And if we manage to specify the data in a way that it allows you to read the previous state and the new one, you're good to go. So we consider the synchronization layer, what we saw on a diagram, as a really tiny thing, tiny plug that can be inserted into all the mutable things we want to synchronize. And all of the changes are collected in a single flow. So they're forming a log of such events, and then it transcends them. Even though it covers that for the simple cases, meaning that we are now able to pass various changes from one side to another, it's not always enough, because if we're talking about the typing, you surely don't want to just receive an event that some character was typed. You as a user, you want to see it immediately, right? Not the moment it was accepted on the server and then confirmed something. So you need to see that. That affects the latency, and that's one of the problems we want to beat, because the people are tired of the typing latency in the remote desktop solutions. So we need to come up with some scheme we will be able to perform optimistic updates, even though it's not correct. How do we do that? You can see that IntelliJ IDE and all other IDEs, they provide typing assistance, meaning that if you type some character, maybe it's a bracket or brace or a quote, or you press double slash to insert the comment, the IDE will help you, and it will change the position of a card if you type enter or something, or it can even invoke the reformat and make your code look prettier. But if you look carefully at the animation that I have here, you can notice that there is a certain lag between the second brace is inserted after the first one. And that's the effect you won't be able to see in the local IDE, because the local IDEs, they do that synchronously. And what happens here is that we insert the first one and we pass it to the server at the same time. And then when the server is ready and it understands that this particular brace wasn't inserted inside the string literal or inside a comment, so it's actually a block of code, and it would be better for an IDE to insert a closing bracket, it will perform that and will send the changes back to the client. But if we have low connection, we can actually see these glitches. I tried my best to opening the biggest file in Kotlin that I found, but it's still not that visible, but you can see that. Here's another example about the smartness that IDEs provide you with. It's the synchronous typing of the tags inside HTML. So you start typing in one place, but the second place is also modified, because it's really convenient to edit the tag only once, not twice. And you can see that if we type very, very quickly, you see that the first one is a bit desynchronizes for a moment or two. And that's exactly the reason, I mean, the optimistic update and the fact that the other IDE is located on a different side of the network is the reason for that. Because we we got rid of synchronous and the knowledge on the client side. So I hope that helps. So the pipeline for the workflow we just saw is the following. If the user types something, it gets immediately inserted, but at the same time, we're forming a request. We added it to the queue, which stays on the client and basically waits for the server to confirm it to be deleted from that queue. On the server side, we just waiting for such requests to be received. And we also attach the version to each change. So we saw that it's important for the changes to be descriptive enough and to define the previous state and the current one. But it's also important to attach some increasing version, so the server can actually change that, can actually tell that this change belongs to this particular version of the current state of the IDE, because it's not something from the future. It's not something that it's haven't seen or didn't expect to see. So now the important thing here is that the server can actually have something different already, because there are two parts. There could be some Git pull launched just a few seconds ago. So, and now it's finished, and the sources on the remote machine is different. Or in the case of coded me scenario. There could be some other users who changed that document beforehand, and you haven't seen that before because everything is asynchronous and you're on a different side of the internet, right? So what the server does, it receives the changes and instantly checking the version, meaning that it tries to tell whether this change is expected, whether it's the next one compared to the one I currently have. And if it is, and applies them and send back the results. What I mean by the results, we saw with the synchronous tag editing in HTML. So you press one character, two are inserted. And that second character is exactly the actual result, the result of the smartness the IDE can provide, and the smartness the client has no idea about because it has no knowledge about the languages. And so we insert one letter, see it immediately on the client, we send the request, but this particular letter in this position with this document version is inserted. Server gets it, applies them, and see the actual result of the typing assistance. And if it's good enough, the client then receives the actual changes and applies them on top of that of the things that they currently has on the client side. And if it's a no match, then nothing is inserted at all. So from the client side, this request engine is also a bit more complex than we saw on a very first slide. So it receives the result from the backend and sees if it was a success. Like if it is, it means that we can apply our results and send the next, send it up in the queue. And if it was a rejection, what it means that because we have the single flow of the changes that we received the reject. Yeah, basically the server is changed. But to get that, we had to receive some actual changes from the server. So it means that if we receive a rejection, that means that at this point, we should be getting a conflicting change. So we apply this change from the server because we consider the server as a single source of truth. All the files live there, and what the client does, it takes all the requests it's accumulated of the time because people can type instantly, right? And it takes all of that and invokes reverts on all of them and basically undoes all the changes. And because of the format of the changes that we accumulate, because of the previous state that we store in that events, we can perform that. And we go to the opposite side, so we reverting all the changes, and then we apply the actual current state of the server which was received, and then we're trying to reapply everything in a reversed order. And all the changes will be slightly different. The ranges can be adjusted, etc. And then we'll get the new queue of the changes that should be sent back to the server. And eventually, all of such workflow, it will result in the single exact state on the client on the server. So about the conflict resolution, which we haven't talked about yet that much, some really trivia and one-on-one stuff. So if you don't have a shared state, you don't have conflicts. That's the point one. We will be using that. Another important thing is that the more granular changes you have, the less ambiguity and the more the easier for you to recover things. Take I don't know, Git as an example. It operates on the lines. So if you have a merge conflict, that means that somebody changed exactly the same line as you did. But imagine how if it was operating on a file level. So if you modify the file, the Git would consider it as a conflict. It would be a huge mess. And even with the lines, we're sometimes not that happy about it because there could be some more smartness that applied to that. And it means that we want things to be more granular. And if we send the changes to the server as the text modification of the bigger ranges, we'll more likely to face the conflict at some point. And if we make it like as small as possible, meaning that we'll pass all the caret changes, all the singular caret change and all the type, all the letters separately, it will be easier for us to adjust and to get the resulting state on that. And realization in the versioning is also important because it allows you to reason about the changes and the way we can approach the conflict resolution and what can we do. Can we merge some particular request? Can we revert them and then apply again? So these are the basic ideas, right? So I mentioned already that the data on the server is considered a single source of truth. If something changed on the server, it stays there. And if the client did something and it didn't succeed, that's too bad. We'll try to recover from that, but no guarantees. Like if it's really, really bad, we won't likely to see that because we made our changes as granular as possible, but still guests can be left with some results they don't expect to see. That's normal. And all of these things that we discussed, it's the what's required for the single user scenario in remote development, because they mentioned the case with the Git pull on the background or some changes made on the server, because it can, the IDEs can do something with the project and it can take time. And at the same time, you have a completely isolated machine on the client, which you're also working with. So you have conflicts already, but if we want to make the things multi-user, we will see more conflicts, way more conflicts. And another important thing is that we will have to divide some state. All the things we defined as something we want to synchronize, meaning the editors, tool windows, some pop-ups and UI elements, the actual state for that, meaning that is this button pressed, is this checkbox unchecked or whatever, it's all stored somewhere, right? There is some class, some instance of a class storing that particular value, which is used later on to show that it's the particular settings is checked or not. So if we want to go multi-user, it's quite obvious that we have to have several like instances of such states. We need to multiply that. And another important thing is that given that IntelliJ IDE wasn't ready to be multi-user, it has no notion of the client whatsoever. So it's just the features, the bunch of the various APIs that can be used to modify something. But if we want to get back the results to a proper place, we need to understand who actually initiated some particular activity, right? So here are our problems with the multi-user scenario. All the conflict resolution stuff is really relevant for the single user already. We just need to make it better. And we also need to find the states and their splits. And we need a way to tell who exactly started some activity. This is crucial. So yet another example. It's very convenient features. It shows you the usages of some file. You can comment over it and then click, and you will see that the IDE will show you the usages of the symbol you are clicked on. And in that particular case, we have two usages, right? And it has a lot of various filters. So you can tell whether you want to limit your usages to only particular folder, or you want the right usages, or you want to merge them somehow, etc. So it's a piece of UI shown after some user invoked it, right? Keep that in mind. There's also a different behavior. If we delete the second usage and we try to repeat this action, we will be immediately navigated to that single usage. So we have the feature which shows usages, and basically it has two different outputs. And one, it changes your active editor, and changes the caret position to the symbol you were referring to. Or if it has several usages, it just shows you the pop-up with various options for you to modify and then relaunch the search. Okay, and how does it look like from the code perspective? All the action invocation starts on the UI thread, and it does magic with matching the shortcuts, etc. And then the particular action is selected based on their availability and the context they were invoked into. Then some preliminary job and work is done on the UI thread, but more likely, the smarter the action is, the more likely it is that it will just launch some background activities and spread through the thread pool some searching or some checking or whatever. It will take time, and while this thing is performed, the user will be prompted with the progress, which they can cancel or just track how the things are going. So we'll go to the background thread, and when it's done, depending on the amount of the usages, we will either change the active editor or show all the available results, just as we saw on the animation, right? And given that the editor is something that should be different for each user, we need, at that point, in the end of the operation, we need to tell which user in the collaborative session needs their editor to be changed, or which user should be prompted with some panel, because you don't want somebody else's to change the editor if you press something, right? Or the same as you don't want somebody else to see some dialog or panel in front of you when the people didn't expect it. So it's very important to track the origin of the activities, and we approach that with the client ID, which basically a thread local variable, which automatically getting passed through all the different changes of the execution. So if you were on a UI thread and you decided to go to the thread pool, it will be transferred there. And if you decided to go back on the UI thread again, it will be there at that moment. And it also integrated with all the APIs within the IntelliJ platform, including the Kotlin coroutines, etc. So basically, it's like a thread local variable which didn't get lost on the thread changes. And it defines the scope of a certain operation which was initiated by the user. And the flow what we saw here is looks like this, with the client ID covering all the important stages of that execution. So you will actually be able to tell at all points of that workflow who exactly initiated that. It has some problems with this also. So if you end up calling some recurring activity or some activity which didn't actually relate to any of the users within the session, you will get over synchronizing. So imagine yourself launching the daemon, something which is periodically performs some analysis of the files or something, and it covers all the project, not a particular user, because there are a lot of different activities related to the project itself and their health and state, but not the people who are actually working with the IDE. And we need to make sure that the client ID won't be saved in such activity, because such activities will be longer than the particular client's connection to a server, right? So we need to define some special client ID telling that no client here is allowed, and to separate changes which are and the features and activities to one which are client-based and they're designed to serve the client with particular features, or they're IDE-based, or meaning that they're responsible for the overall state of your code or a file system or your documents or whatever. So it's really, really important. And as for the state, what we wanted to have split it, it's Obviously, it's an active editor because a lot of various features are only work within the open editor you're currently working with. It applies to completions and various tooltips and pop-ups that you see inside the editor. But also you need to get the list of all of open editors for the code analyzers, right? And the code analyzer will get the list not only from you, but also from all of the users working within the Code with Me session. The same thing applies to the tool windows and to the state within the tool windows, such as we wanted to track the caret position within the editor, we want to track the selected element within the tool window. So it's not a lot of things, but some state what we need to split. And what's the way we go for that? So basically, if we talk about the way feature works, we defined already that some of the things are not really related to the particular user. They're just to serve the application, like they know about your code, your project. But the features, which covers all the user interaction within the IDE, it also produces some visible elements on top of that, or it can take a look at the predefined settings to tell whether it's something that should be done or not. The settings are used to modify the way feature work. So these are the things we want to separate. And with the client ID, it looks like this. So we get some changes for the protocol. We enter the feature section. We pass the client ID through all of the execution workflows here. It doesn't matter how complex it is or how hard it was to implement that particular feature for refactoring or for some complex navigation or looking for problems and analyzing. It doesn't matter because the only thing we care about is that at some point this feature will produce something visible, or it should be altered depending on the particular setting chosen from the user who initiated that change. So we split that change, split that state for the things we need, and we also remember that we have the synchronizer attached to all the relevant parts of the UI or the settings or whatever system it is that we want to synchronize to the client. So the client ID here is passed through all the execution flow, and at some point we'll get something back to the protocol because we synchronize everything and we didn't lose the knowledge about the person who initiated that change. It's also important not to split the state as it is, but also to change the behavior, because if the local user does something, the actual UI should be shown. But if there's the remote user connected to the server, or it's a guest within the code with me session, no UI should be shown on the server side. And there's no way to show UI from the server side to the client side if we don't fall to remote desktop solution. So we need to get some state for that and send it through the protocol. And on the client side, we show the actual UI. That's why all the UI is local there. So we want to split state, but we also need to change the behavior. And there are a lot of various things not immediately obvious what we want to split, such as undo stacks, for example. Because if you do something and you press Control Z or Command Z to undo that or to redo that, it's one of the things you are so used to you don't even think about. So at some place within the IDE, this stack is stored with the actual changes you performed. But if you're working within the same file as your colleague that you joined with the Code with Me session, you don't want to undo somebody else's changes, even though they're within the single editor, right? So we need to split that. The settings we mentioned already, and it also applies to the various features shown within the editor itself, such as UI, etc. So this brings us to the need to be able to transform various UI elements in a general way. So we are mostly okay with the editor because the only thing we need is the caret position, the text, some visual elements. We're done with that. But what about the tool windows? All of them are different, and we don't have the needed knowledge about that on the client side because they usually operate with some package management or some language tools or some test frameworks. All the knowledge this feature has to get is on the server side, but we need to show that on the client, right? So we came up with the solution where we take the UI and we run a cascade of the transformers for them because all the UI elements they're not even in HTML. You define the nesting, you define the DOM, and in Swing, which is the UI framework that IntelliJ is using because it's a Java-based application. There is also some notion of that tree of the UI elements and layout on top of that. So we take the basic, the topmost component within the tool window, and usually it's something really simple like panel, which a mere holder for various UI elements. So we take them and we recursively, top to bottom, go to all the UI elements and we transform them. And given that we know about nearly all of the controls used for the UI, because the server and the client has the same platform, they share a lot of code. So the only thing we need to do is to get the proper element there, extract all the needed like things you need to replicate that state on another site. The same we did with the editors. Like if it's a button, is it pressed? Is it disabled? Etc. And we also need to subscribe to the changes and pass all of these changes into the same flow as before. We do that, we pretty fine with the conflict resolution automatically. And we also getting the various pretty complex features on the client side for free. And the important thing here is that we don't even care about the type of the feature here. The only thing we care is the way it's shown. So, and we do it in a way that it's completely asynchronous and it's ready to be to clash with somebody else's changes. But we split all the needed state, so we get rid of a lot of conflicts, and we also make the changes as granular as possible, which also reduces the amount of possible conflicts. And then if we do all of these things, we'll end up in IntelliJ IDEA or PyCharm or various or Rider or your favorite JetBrains IDE. Not it's a server, like it's completely capable of serving several types of clients, or it can be moved to another machine. Yet we didn't make it like a server from the regular point of view, so we didn't get rid of the state of it, but it seems like it's not such a big deal. I mean, we would like it to be so, but it requires a lot of different changes. And the same thing with the UI transformation as with the tool windows can be made with various types of the UI. So we seen that already, this panel with the filters, and we also can take a look at that and realize that there are a row of the buttons with the similar state. There's some drop down, there are some settings here, the icon on top right to move that to the tool window, which we also synchronize. So if the user presses that, we'll get the result because the tool window will be created, and we'll also synchronize that. So the important thing here is that because we stored the state on the server side, we didn't get rid of it. We get all the feature intersection for free. So if some features produce some visible UI, show some progress, then changes the editor, then shows some dialog, then creates a new tool window, and then does whatever it can imagine, we will get it just because we synchronize all the important visible bits And we also didn't get rid of the state on the backend, because all the features, even from the third-party plugins, they are running the same way they did. But we will be able to get all the results. So the final take about the strategy, we transform the IntelliJ platform slightly in a way like we separate all the needed state, we split it, we multiply it, we get all the needed data, and we attach listeners to that. And we refactor all the features within the platform or various code, which depends on the focuses, concrete colors, or some pixels or display dimensions. So if we move to more structural information there, we will be able to pass it. And then it's the same old story about the creating the exact copy on the client side. And that brings us with the majority of the code left as is, with a certain things separated, certain behavior switched, and we treat all the synchronizers as a really thin layer, which provides the correct order of the things, or of the changes passed between the two ends, or several ends between the, in case of code with me. And that's it. So I have two things that you can think about later on. We didn't cover the user permissions, because in Code with Me, you can invite read-only guests. They won't be allowed to do any changes, but will be able to see some files or navigate for that. And how would you approach? I want you to think about it. So how would you approach such feature? Because it's really necessary, especially for the classroom scenarios. But there is no such feature as a permission management within the desktop IDE. It wasn't needed. But given that we know who exactly initiated some change during the whole execution, we can probably take a nitpick and tell whether it's possible or not for this particular user. And another thing is follow me feature is that when inside a code with me, you don't work independently, but you follow somebody else's, like a caret or active editor or the focus in the tool window. And basically you it's like screen sharing, but more structural and fast. You see the same things. You can even invoke that 2 times, so you will be in a full sync mode. And how to do that, given that we already implemented the synchronization between the two parts, and then it seems like we need something different, but quite similar. So this is the homework. I hope you will have time to think about it. So yeah, and a little bit of the future, even though we defined the way that it's absolutely fine for us to have state, we will gradually make it less stateful, and we also make the client more thicker, and we'll cover all the missing complex things within the IntelliJ platform on various IDEs, which are not currently covered. There are not a lot of them, but some there. And the major goal here is to make all the APIs to be ready to be used remote and collaborative by default if they are paired in the future. So that was it. Thanks for your attention. I would be glad to answer some questions. It seems like we won't have a lot of time, but maybe a couple of them. So I'm passing the word to Kir.
Wow, that was amazing. Very, very interesting. So you basically take an IDE, which is super complicated, like asynchronous, complicated desktop application, and you take multiple of the other IDEs and you try to bind them in asynchronous way and,
Yeah,
and make it consistent and fast.
sort of, yeah.
Yeah, I have a question about, like you said, there is lots of state and you have plans to make it more stateless, but there is another product on the radar, which is VS Code, which is completely stateless from scratch. And the LSP protocol is completely stateless, and all they do is just RPC calls all the time. So, what is your perception? How do you think it impacts the product? So how this technological decision impacts the product in a
Okay.
general way.
Yeah, the first thing that comes to mind is that if you define all the features in RPC-like way, you need to define the type of the responses you will get from that call, right? So you need to tell up in front what type of the functionality will be available. So if we're talking about the IntelliJ setup, where you have different subsystems, they're mutable, they're changing data, but that allows you to create and come up with whatever behavior you want. So you want to select some elements in the project view on the declaration, go into the declaration because it's some symbol from the library. Okay, go for it. All you need to do is just write the code to focus that exact element. If you need to change the editor or do something else, you basically just write that code to specify the behavior. If we're going with the RPC, it's really hard to come up with all the possible scenarios. And if we list all of them, it won't be enough anyway, because sometime later, the guy will come up and say, oh, I want that feature to invoke something different, and that won't be simply possible. But with the particular features, which are pretty strict and not extensible, it works really well. So you're not that limited in the imagination if we talking about the quick documentation. Well, you see the documentation, you can scroll that, then that's it. This is the perfect example of the RPC feature that can be implemented. But if we're talking about some Python notebooks, you just take a look at the editor there. It has the various buttons and the ways to run the application. It has an extra mixture of the text that you actually wrote and the output for that, like graphics and the tables. It shouldn't be possible, like to be written in the RPC-like way. So
Okay, I see. And like it's just amazing. How do you test all this? Like you have all these complications and all these, entities which are asynchronous, and you asynchronously bind them together. How do you manage to test all this stuff?
that's a whole different story. Like it deserve a dedicated topic. Like maybe an hour would be enough for that. And also a lot of different things that I didn't talk about that are also
Yeah, maybe
very
we can
interesting.
discuss this in a
Yeah,
discussion room,
yeah,
right?
I would move that to the discussion section. So yeah,
Oh,
thank
okay.
you.
Yeah, thank you, Sasha, for an amazing talk. Thank you all for listening to us. So we'll meet you in discussion room. Thank you and bye.
See ya.